be on video.
This call is now being recorded.
So welcome to this session on how do we build thinking in mathematics. So this is something I found very beautifully written in the NEP, which is National Education Policy. Although thinking in mathematics is something which is very universal, it is central to all the boards, all the education material. NEP says pedagogy must evolve to make education, and I'm only looking at the highlighted words, inquiry driven, learner centric, flexible. So there is a way this can be done, and I will attempt to explore that today. And if at the end of this hour, all of you say that I got one new thing in this hour to practice in my classes, that will be absolutely great. So, first question to you. What is thinking developed through? So, if we say thinking is developed through this, what would you say thinking is developed through? Can anyone answer? You can unmute yourself and speak, or you can put it in the chat box. What do you think thinking is developed?
This call is now being transcribed.
Overcoming
Yes.
challenges.
Questions, challenges, yes, that's true. So thinking is developed through questioning. So thinking is developed through challenges, yes, sir. But challenges also require questioning to kind of take them forward. So this particular session is going to follow 4 questions. So all my sessions are driven by some questions. So the questions I'm taking for this particular session is, first, how do we learn? There are so many question types, but I'm putting all of them into old question types, and I'm giving you a very simple system, which I call as the new question types. And from new question types, I would take you to the art of questioning. And the art of questioning is one of the most powerful tools that a teacher should have. So here we go. How do we learn? Let's break it down. How does learning happening? Tell me, where does learning happen in our body? We have so many organs in our body. Where does learning happen? Can anyone tell me? Does it happen in our feet? Does it happen in our stomach? It happens in heart and brain.
Through the sense organs?
Through the sense organs, but where does it all come together?
Brain, of course.
Brain, of course. Mind, brain. So learning happens in the brain. So what does the brain do when learning is happening in the brain? Anyone can speak. Small groups, we don't have to have raise hand and all. You can also put in the chat box. I'm looking at the chat messages also. So what is it that the brain do in order to have learning?
Does it form a neural path?
Okay.
It keeps collecting all the data.
Okay, it creates neuro pathways. Thinking. Brain does thinking in order to learn. Anything that goes before learning is thinking. And how do we make someone think?
Ask them to imagine.
Ask them to imagine. And what else?
Appropriate question.
Appropriate questions. So to make anyone think, like I'm making you all think right now, yesterday I had a workshop with teachers of MCD schools. So I was making them think. I was only asking questions. So when I used to teach in classes, my students used to say that you ask more questions than you give answers. So that is, and then somebody else said, well, that's exactly how learning happens. So this whole session is, how do we make someone think, or rather, how do we make children think? So let's look at, what do I mean when I say old question types? So we have so many categories of questions. I'm taking 4 here. Closed-ended. Can anyone tell me what is closed-ended? Can anyone give me an example in math of a closed-ended question? From maths, any example of a close-ended? Just listen to the words close-ended and you would know. Okay, let me give you an example. What is 2 plus 2?
4.
4. Can there be any other answer?
No.
That's close-ended. Can you give me another example of a close-ended question?
Any addition or subtraction of a definite number?
Subtraction. Even you can say, what is if x square is equal to 4, what can x be?
Plus or minus 2?
Plus or minus 2. We can. So it's very fixed answers. That is called closed-ended questions. What is derivative of x square? 2x. Closed-ended.
Yeah.
Open-ended is questions which can have multiple answers. For example, ma'am, when I asked you what is x square is equal to 4, what is the value of x? You said 2 and minus 2. And then if I ask you, how do you know it's 2 minus 2, 2 or minus 2? Do you think in a class of 30, everybody will give the same answer?
No, they won't get say that.
They won't get the same answer. So open-ended questions are questions where kids can give different answers. Another example is, how do we know that 13 is not a prime? Again, some children may say not divisible by 2. Some children may say if I put in pairs of 2, 2, 2, 2, 2, it's I get 1 left over. Another open-ended question can be, am I going to get always the remainder 1 if I divide a number by 2? So different kids can give different answers. Another category of questions is Bloom's taxonomy, which is now very much into everywhere. Even CBSE new pattern, and I'm putting the link in the chat box in case you want to know more about Bloom's taxonomy. Even CBSE, when I looked at the new pattern, they have given the new pattern as knowledge, understanding, application, analysis, evaluation, and creative questions. That is Bloom's taxonomy from the guy called Benjamin Bloom. And he said basically your brain has these 6 categories as a ladder. So easiest questions are questions of remembering, hardest is to create. So that is also a traditional category of questions. And then there is a category which is one of my favorites. It's called 5W and 1H. We can also, to remember it, call as 5 wives and 1 husband. I'll put the link in the chat box. This is what, when, why, where, how. Can you give me a question in math that, let's say you're teaching any topic to the children. How will you ask a question starting with what? Can anyone give me an answer here?
Can you please repeat the question?
So suppose you're teaching any topic in maths and you want to ask a question that starts with what? W-H-A-T. I'll put it in the chat box. Can you give me a question that starts with what?
What can be the answer?
Exactly. Can you give me a question that starts with how?
How to go about?
Yes, then where?
If they do some mistake, we can just ask them.
Exactly. And who? So 5W1H is a formula, or rather pattern given that these are questions that you can use. So I am calling all of these traditional categories of questions. And I say that there is a bit of a challenge with these old types. The first type of question is closed-ended. The challenge is it doesn't push to think. 2 plus 2, 4. X square is equal to 4. X is plus 2 minus 2. Is this a binomial or a monomial? Degree is 1, so it's a monomial. Degree is 2, so the number of variables or the degree it tells me whether it's a binomial, monomial. You don't have to think very hard. If there are 2 terms, it's a binomial, single term, it's a monomial, 3 terms, it's a trinomial, degree is 2 because the highest power is 2. So it doesn't let you think very hard. Open-ended is making open-ended questions is a bit difficult. Like even in the group, when I asked, it was a bit difficult for everyone to think. We have come up from education where we didn't get many open-ended questions in our life in math. And we came up with this belief system that one question only has one answer. So we didn't think of it. Bloom's taxonomy universally is difficult to understand and use. By and large, even curriculum designers sometimes end up arguing, is this an application question or an analysis question? Because there are gray areas. So Bloom's is difficult to understand. 5W1H works sometimes, doesn't work sometimes. So these are the challenges with the old type of questions. So I want to pause here and see, anyone has any question or any doubt here? Otherwise, I'll continue. Okay, so these are the 4 type of old questions. So I would say the new type of questions are questions which are usable, which means a teacher can use them in his or her classes. And I call them, this is my personal vocabulary, you may see it somewhere else, but I'm pretty sure somebody else also would have thought of it. I would say starter questions, support questions, ending questions. That's all a teacher should think of. And all the old type of questions can be anywhere here. Starter questions, when I'm beginning a chapter or when I'm beginning a class. These are diagnostic. I want to test how much do they know. These are also questions that trigger thinking. Support questions which support the children when they are learning. So let's say children are working on their own on a topic and I go around and I can use 5W1H and say, hey, what are you doing? Why are you doing it in this way? Especially if a child gets an incorrect answer, how did you get this answer? What else could you have done? Who invented this topic? If I want them to research, I can ask who invented this topic? Where is this topic useful? Where did we learn this before? So those are support questions which drive the students during the lesson. And those of you here who are from Mentor Match, this is what we will be doing eventually in our lessons or even when we are meeting you. Ending questions are simple. End of a lesson before the child exits, there should be something that is evaluated, something where you are testing. How was my lesson today? Did I manage to help the child? Is the child clear? Are there any doubts? So ending is evaluating. So I would say, look at your class, look at your lesson plan as 3 components: beginning, middle, end. It's like in theater, generally a play is 3-act play. Beginning when they build the whole scenario and they make everybody wonder what's going to happen. Middle is when the whole story goes right, left, up, down. And finally, when there is end, when there is a climax. So it's called a 3-act play. So question for you, and I hope others will also answer now, apart from ma'am and sir. Thank you so much for involving yourself. Where do you think you will ask an open-ended question? Beginning, middle, or end? Let's say a question like what we just discussed. Why is x plus 2 or minus 2 when you do x square is equal to 4? Or why are we learning this lesson? Or where did you learn this? Where do you think open-ended questions can be asked? And this can be a personal choice. For example, I may say, when I start a class, I'd love to ask an open-ended question, but then I want to slowly move to closed-ended. What do you do? Beginning? Okay, thank you, ma'am. What do others feel? Can you answer in the chat box? I'll just wait for 30 seconds for you to answer in the chat box. In the beginning, okay, beginning, everyone feels in the beginning. Great. Beginning. Great. End of a class, most of the times kids like to have a closure and they don't like to go with something nagging them that was this answer correct, not correct, what could others have said. Where do you think you will ask closed-ended questions? It can be any situation. For example, if I see a child is during the lesson, if I see a child is struggling with the concept, I may go and ask some easy closed-ended questions. So, for example, a child is trying to solve an equation 3x plus 7 equal to 10. The child is struggling. He is taking 7 to the other side and writing plus. I may ask a very closed-ended question. What do you do when a number shifts from one side of the equation to the other side? And so that the child just gets the answer and moves on. Can anyone give me another situation that this is a situation where 100% I am going to ask a closed-ended question? During the lesson, okay, thank you, ma'am. What else? What do others say? You can also say beginning of the lesson. You can also say end. It's up to you, depending on how you like to teach. Towards the end, that's right. You can also ask, and at the end of the class, suppose you have done addition of fractions, at the end of the class, you can just ask straight away, okay, guys, what is 1 by 3 plus 1 by 4? Quickly solve it and tell me. So the class wraps up. Where do you think 5W and 1H can be useful? 5W, 1H are questions that start with what, when, why, who, where, how. So when did we do this topic before? Who invented binomial theorem? Where is fraction useful? How do I use addition in my life? Why are we learning proportions? What is the meaning of differentiation? These are just random questions I'm giving you. Where do you think the 6 parts of starting? Okay, great. Would anyone else like to try? Where do you think it can be used? Beginning? 5W and 1H? Some people like in the beginning. I think I like it pretty much the whole time. So I start a lesson, and anytime a child says, let's say I start a lesson by asking 3x plus 7 equal to 11, what's the value of x? And a child gives the answer, I will say, how do you know this is the answer? Whether the answer is correct or incorrect, it doesn't matter. How do you know this is the answer? How do you know this is true? What else can the answer be? Suppose I ask x square is equal to 8. What's the value of x? And somebody just says 2 root 2. What else can it be? And somebody else say minus 2 root 2. I would say, what else can it be? Till the children literally rack their brains and say it cannot be anything else. So 5W and 1H can be used everywhere. So what I would recommend is education pedagogy will keep evolving. More and more types of questions will come. I didn't touch Bloom's taxonomy because that will be another session itself in the coming weeks. I try to do a session every Saturday at 6 p.m. I would say you will have open-ended questions, close-ended, 5W, 1H. There is also 7W, 1H. There is Bloom's taxonomy. I would say as teachers, consider all of these tools. Like a carpenter has a toolkit, have a toolkit, put all these questions in the toolkit. But remember, there is a beginning, a middle, and an end. And just think, okay, I'm going to use this either in the beginning, middle, end, or everywhere, because a classroom remains a 3-act play. The classroom doesn't change into anything else. So this is what I would call empowering a teacher. And so just have these 3 as your main questions. So now here is the check for understanding time, CFU. I'm going to give you a question and either you can unmute or put it in the chat box. Is this a starter question, supporter question, ending question? It can also be a gray area, which means some of you will say start, some of you will say end. And a lot of you are participating now. It's great, but it'll be great if others also participate. What is the value of X in the following? It can be anything. Starter, supporter, or ending. Please put it in the chat box. There is no right answer, no wrong answer. Somebody can say, I can use it in ending. Somebody can say, I'll use it in starter. Somebody supporter. Just looking for you to think a little. Where do you think this is? Starter, supporter, great. Supporter. Okay. Anyone else would like to answer? Starter, okay. How will the answer change? Let's say there's a word problem. How will the answer change if instead of 50, I take 500? For example, the question is, I had 50 bicycles and I sold all of them and I earned this much. So now I'm asking the kids have solved this and I'm asking them, how will the answer change if it instead of 50, I take 500? Starter, supporter, or ending? This is actually pretty obvious. Supporter, yeah. It can be supporter, it can also be ending. I can also end the class by taking any problem that I have given. For example, yes, supporter and ending, both is possible. Suppose if and I'm trying very hard to shift between primary, middle and high school because I know the teachers are mixed. Please, if you feel that you are not being covered, just ping me and I'll try and take an example. Sometimes teachers ask in the workshop, Pam, can you take an example from fraction? Can you take an example from decimal? So for example, I took an example from money here. I can also say solving 2x plus 3 is equal to 7. I can ask the children, what's the answer? Then I can say, how will the answer change if instead of 3, I put 13? If I say x square is equal to 4, x is 2 minus 2, how will the answer change if it's the power 2, the power was 3? Or the power was 4. So just getting kids to stretch a little. So that's I would use this as an ending question, but yes, it can also be used as a supporter question. Okay, there's a word problem with Seema, Reena and Babita. And the question is, what is it that Seema, Reena and Babita are going to do? Starter, supporter or ending? Ending, okay. Anyone else? Ending. This, I think, is a supporter question. It can also be starter. A word problem is given. Children are trying to solve. And the first question that is asked is, what are the 3 girls doing in this problem? So this is starter or supporter. Ending would be the answer that comes and we may ask, are you sure the answer is correct? What do you think? Will Seema get more or will maybe Babita get more? I think this I have already answered, but what do you think this will be while the children are trying to solve a word problem? Ending or supporter? How do you know if this answer is correct? This is very, very obvious. Is this starter, support or ending? How do you know if this answer is correct? Guys, come on. So I asked 2 plus 2, answer is 4. And I'm asking, how do you know is this answer correct? Generally ending. Whenever the answer comes ending, but it can also be, ending can also be like ending a question in the middle. It can also be a supporter question, but generally towards the end. Finally, this is also very obvious. What's this problem about? What is this question about? When do I ask? Do I ask starting, supporting, or do I ask in the end? Supporter, what is this problem about? A child is stuck, what is this problem about? So these are starter, supporter, or ending questions. So now, I always show videos from the teachers to teachers in the classroom. Let me show you a video here and let me know if the sound is not clear. You can put it in the chat. This is a video from Common Core State Standards, which is a US-based program. However, I would say working in IB schools, I've met teachers from so many different nationalities. I think teachers are teachers everywhere. So let's hear what these teachers have to say about questioning.
We want to change the relationship between the population and mathematics. And we want every student to experience mathematics as something of theirs that gives them the power to think in ways they wouldn't otherwise think.
All right, Trizelle, so do you think that's a function or not?
We need to value kids asking questions and saying when they're not sure and saying when they're wrong. It's not just reviewing stuff kids should know. It's giving them repeated opportunities to make sense of what we're asking them to learn and see the connections among topics.
What is number 5 doing?
It's quadratic. It's quadratic, you've got x squared plus x.
There's one thing that I'm often saying, we're here to ask questions, we're here to find things out.
When there's lots of uncertainty, that's what mathematical discourse sounds like. That's what productive discourse sounds like.
For the acceleration vector, did you guys simplify?
Would you be willing to talk about what you tried and how you know it didn't work? I really want students to be comfortable not knowing things.
I have a question, because when you add in the horizontal asymptote, then the curve can't go upward for infinity, so does it start curving this way, or?
No. Everyone feels comfortable and everyone feels like even if they say the wrong answer or they get something wrong, they're not going to be discouraged.
Questions are a way for the students to either solidify their understanding, to convince themselves of their own understanding and be confident with their understanding, or conversely, to find out that maybe they don't quite understand it.
It's about demystifying the process of being wrong.
And it would be plus, right?
Yeah, because it's moving to the...
I want to make sure that the kids in my class are wrong frequently, because otherwise I'm not challenging enough, I think. And secondly, because if they're not wrong frequently, then the few times when kids are wrong, it might feel like their dirty little secret.
Solving some equations. Becca. The kind of culture I'm hoping to create is a culture where students have a strong ownership of the classroom and of the mathematics.
I really like this math class compared to my other math classes last year. She loves to keep us involved. It's really energetic.
Do you have a brave volunteer to talk about what felt funny or wrong or strange? Amanda?
There was one point on the x-axis, there was like
Okay. Can you tell me, this is my favorite question after I show a video. Can you tell me any one thing that literally stood out in the video for you? Like it was about 2 minutes, 42 seconds video. What is the one thing that you really felt, yeah, I liked this a lot, or I'm going to use this, or I do this in the class? You can put it in the chat or you can unmute yourself. Is there anything that you feel that I really liked this in this session?
The class was quite interactive.
The class was interactive. Okay, great. Anything else? Anyone? Like I really liked what the gentleman said, I would like children to be wrong frequently, otherwise I'm not challenging them. That's what I liked. Anyone else would like to share? Thanks. Let's see, ma'am. Okay. So the art of questioning is the art of being able to use starter, support, and ending questions. So I'm going to go a little bit into it. How do we make starter questions? How do we make support questions? How do we make end questions? And there are a couple of resources on this PPT. And I will be giving you this PowerPoint itself in the WhatsApp group, so you can explore them later. Starter question is, first thing is just identify the topic. Let's say whichever topic you are going to be teaching today or tomorrow to the children, identify the topic. Think of any standard question. For example, generally, if you're teaching subtraction, a general question would be, what is 12 minus 13? And then think, can I ask this question in a way that it becomes an open-ended question? So I'm going to maybe give 10 seconds. Can you think of a way you can introduce square by not asking what is a square, but in some other way? For example, when I asked this to teachers in a school, they said, I will bring a square-shaped object. I won't say what it is. It can be a coaster, like this coaster on my table. And I would just say, tell me something about this. And then I'm going to come gradually to square. Different children will say something, different thing. Would anyone like to try? 10 seconds and then I move on. So what do you notice about this? So they might say, this is a coaster, it's brown. Then I would say, what do you notice about its shape? So it has corners, it has sides, and slowly children will 100% come to 4 sides, all are same, all angles look like 90 degrees, and then I'll say this shape is called as a square. Similarly, you can think of, let's say I'm starting functions for the senior school, I'm starting equations for middle school, I'm starting with subtraction. How do I ask so that it becomes an open-ended question, or I am asking them to give me some answers to the previous knowledge? For example, I may say, maybe I can use easier numbers. I had 100 rupees in my pocket when I went and I bought something. Let's say I bought vegetables, or kids, I bought a pen for 27 rupees, and I'm wondering, do I have enough money to go for a movie where the ticket costs me 83 rupees? So I may start with a question that gets kids to think a little bit. Or I may give a word problem and ask them, do I take away, do I add, do I subtract? So something like a twister. That's how starting questions are made. The whole objective is get the kids to think a little. It can also be testing previous knowledge. Then it may be a simpler closed-ended question, but get the kids to think a little bit. Like, where did we see this symbol before, the symbol of subtraction? What did we do there? Did we have 3-digit numbers? What did we do? How do 2-digit numbers subtract? If it is equations, then if they have already done linear equations, then quadratic equation, then they say, okay, 2x plus 3 equal to 7. What happens if I put the power 3 for x? What does it become? Is this still a linear equation? So starter question is like an icebreaker, which can be done. Supporting questions are interesting. Supporting questions, children are generally at 3 stages in a class. One is children who are completely confused. Ma'am, can you please be on mute? Setu, ma'am, can you please be on mute? So let's say there is a child who doesn't understand at all. The child is confused. Then there are supporting questions are called as clarity questions, that you want the child to come to clarity. I'm going to come to examples of this. CFC, a child understands a little bit, doesn't understand completely. Then you need to check, where is the child clear, where is the child not clear? And accordingly, you ask questions. I think this is something all of you must be doing already in the class. Third is CFU, a child understands completely, but as teachers, I need to understand, does he really understand? So that is a check for understanding questions. So there are 3 types of supporting questions: C, CFC, CFU. Now here, can you tell me which one is a give clarity situation? Which one is check for clarity, which is check for understanding out of 1, 2, and 3? You can write in the chat box, you can write something like 1 is C, 2 is C, 3 is C, like that you can write the answers. Giving you 20, 30 seconds for this. Which of the 3 situations? Situation 1 is, what do you need? And so I'm a teacher talking to a child. What do you need to find out? How would you describe the problem in your own words? Can you try this with simpler numbers, fewer numbers? So there's a clue hidden in each. Type 2 is, why is your method correct? What if I replace 5 with 1,000? Can you explain your thinking to me? Can you create another problem like this? And third is, I'm asking the child, which words are important? Let's say it's a word problem. Where are your issues with this problem? Can you try a different method? Can you draw pictures? So what do you think 1 is? Is it a clarity? Is it C, CFC, or CFU? The situation number 1. Anyone? Do you think this child is completely confused, little confused, or completely clear for situation 1? CFC, okay. Anyone else? Thank you. CFC. It could be C, it could be CFC. Because when you're saying, could you try this with simpler numbers, it means the child is confused. For example, if you're giving a child question like 32x minus 217 is equal to 42x and solve it. Child is stuck. Could you try this with simpler numbers? It's actually gravitating more to C. It can also be, I've given 3-digit numbers to subtract, the child is stuck. I'm saying, why don't you try this with 1-digit numbers? Thank you. What about 2? 2 is so obvious. What is 2? It's a CFU. Can you explain, anytime a child gets an answer correct and you want the child to still keep thinking, can you explain your thinking to me? Can you create another question like this? So that is a completely CFU. And the third is, did you try a different method? Generally check for clarity. What are your issues with this problem? I'm checking for clarity. So if a child says, I don't get it, what is your issue with the problem? What is confusing you? So I don't know why this degree is 3 in the answer. I don't know why my answer is incorrect. I don't know why, let's say a child has done 12 plus 19 and the answer is 211. I don't know why my answer is wrong. So what confuses you? That is, check for clarity. So these are generally the 3 situations that come in the classroom when you're doing supportive questions. Ending questions are the easiest under the sun. Option 1, one of my favorite when I was teaching journaling, giving the children, I'm giving you 3 minutes to answer this question in descriptive English. What did we learn today? Explain to a friend how we subtract decimals, or explain to a friend how do we use discriminant to find the nature of roots of a quadratic equation. Or if the topics are scary, like some kids are afraid of algebra, or they are afraid of trigonometric identities or fraction adding using different denominators, how do you feel at the end of the class? That's journaling, option 1. Option 2 is questioning or simply having a quiz. Questioning them. Which one of these is a square? How do you subtract these two? Solve one problem. Another favorite of mine in high school used to be giving the children one problem and 2 to 3 minutes to solve it. I'm giving you, let's say, once I even gave a question for 30 seconds and I marked it as a formative. I said, I'm giving you one equation. Let's say 4x plus 7x is equal to 19. Solve it in 30 seconds. Tell me what your answer is, and instant correction also happened, right or wrong. So that's the other way. And good old worksheet is the third option in ending questions. Give the children few problems. Always set the time. Always say, solve these, and I'm giving you 17 minutes or 11 minutes, and set the timer so the children have a bit of a boundary. Or say work with a peer or work alone. That is the ending question. Has anyone got an idea to give another type of ending questions? Is anyone creative teacher here? Do you try anything else? How do you end a lesson? Journaling, quiz, questioning, or a worksheet? Any other idea? Questioning, okay. Thank you, ma'am. Okay, so second and the last video here, notice the teacher. I'm not going to play this fully, maybe just for 2 to 3 minutes. I want you to simply observe what is her starter question, then observe how she's asking support questions. And if I am able to end the video, but otherwise you will be able to notice in the middle also how she ends. Like she begins one sequence, then she ends. Then she begins and then she ends. So the previous one was a high school. This is, I think, either late primary or early middle.
Bring it back in 3, 2, 1, 0. Number 1, I want you to be coming up with a conjecture. And number 2, I want you to be coming up with a reasoning or justification for why. Now, how are we figuring out what this conjecture is about? I want you to think about the 3 problems that you just solved, as well as the number sentences that you created to go along with them. And if you look at your pages right now, the last bulleted question says, do answers always get bigger when you multiply or smaller when you divide? Why or why not? Your conjecture is going to be based off of this statement, and you're going to use the problems that you just solved as well as your number sentences to help you figure that out. When I say go, you can get started with your table groups in trying to figure out that conjecture. Is that always true or is it not? Do you have another?
So that's how she started. She has given them the starter question.
Another example without using 1, because you know when you multiply and divide by 1, you're always going to get that same number.
4 times 1/2.
What's 4 times 1/2?
2.
Which is what?
2.
That's a great example. You could use that.
Okay, so we could go.
What's your conjecture?
When you multiply a whole number by a fraction where the numerator is less than the denominator, the product will always be smaller than the whole number.
Okay, where's your example and reasoning? I need you to prove it.
So watch how she is using where, what, why, how, all of these in her supporting questions as she is supporting the children through this.
Voices off! Drop everything! So, who can remind me, what is a gallery walk, Josangeli?
Gallery walk is when
And now she's ending the first segment of the class.
different groups make posters. We go around and put posters and tell the group what was good about their poster and what needs to improve.
Okay, can someone remind us, what was our goal for the next time that we did a gallery walk?
Don't always write that someone is not being neat.
We need to make sure that we're being specific. What else? Michelle?
We have to actually tell them what's good about the.
So I'm ending this here, as and when you get the PPT and the videos, do have a look at fully. So I just wanted to show you one section of her class, how she started, then how she supported the kids, and ends with a gallery walk. The subtitles are auto-generated, so some of them are literally weird. So the kids put up their work over on the walls and they walk around and write comments on everybody's. That's how she is ending one section of her class. The class goes on and you can say. So basically, whenever inquiry, or rather whenever we have a question in class, we should have starter questions, supporting questions, ending questions. Ending is conclusion, starter, supporter, ending questions. And I think as a practice, I have given you here another link which you will get when you get the PPT. Just when we end, I think within 15-20 minutes of ending the workshop. I think when you want to practice this for your class, take your next concept. Think of a starter question. Think of 3 support questions for C, CFC, CFU. And 1 support for conclusion, that is ending the class. Think of this when you're planning for the next class, and then you can see how exactly your class goes. See, is it making a difference to my class? If I, when you go to buy a car, I don't own a car, but I've seen this. When you go to buy a car in any showroom, you don't just buy a car. No, the salesman says, here's a Maruti, here's a Honda City, here's a Mercedes. Drive and see for yourself what do you like. So I would say, drive with these questioning skills and see, is it making a difference? Is it helping my class? Is my lesson getting better? If it's getting better, please use it. If it's not getting better, drop it. Consider yourself like, this is like a tool I'm adding to your kitty, and see if it works or doesn't work. So my last question to you is, as you can see, I love asking questions while I'm putting the feedback form, which I would be very happy if you can share. What do you think is the one thing that you have learned today? Can you put it, can you unmute yourself and share any one thing that you've learned today that you feel, I am definitely going to use this in my classes? And while people are answering, if some of you can fill the feedback form, we always feel, that feedback to aana hi chahiye. So if you can tell me, what is the one thing that you learned today? something new. I'm like very eager to know whether how fruitful this session was. It can be anything that you learned today. You can also put it on the form, or you can unmute yourself and speak. Start, support, ending questions. Thanks, Mr. Ajay.
Ma'am, good evening, ma'am.
Good evening, ma'am. Hanji.
This is Setu here.
Yeah.
I am actually a primary school teacher, maths.
Okay. Okay.
When we generally teach in our class, it is always, I have been taught as that, we should ask a lot of many questions in between,
Yes,
so that, the class is live, interactive, it doesn't get boring. But
Yes.
we have been asking, but we never, I did not, never found it out that, it should be a starting question.
Yeah.
We have been doing it, but this
Yeah.
was great. Now I can focus more on starting, in between, and the ending questions. So those
Great,
questions which can be asked on the proper time, which hits more,
Yeah.
and the thinking goes on amongst the
Yes.
children's brain.
Yes. Great.
So I will
Great.
focus more on that. Thank you so much, ma'am.
Great. Thanks a lot for sharing this. And I think this will be with most of you who are teaching for a long time, or you are like expert teachers. You would know, you would also feel ki we knew this, we just didn't know that it was called starting support. Yeah. But great, even to have vocabulary, like you rightly said, that it focuses you very well, that okay. And also you will get tons and tons of new ideas in workshops, but you just need to say, okay, where do I place this idea? Do I place it in starting, support, or ending? And it makes knowledge a little bit more organized. And thank you, CFC and CFU terms. You learned that. That's great. Anything else anyone would like to share, or please start putting feedback. And this is now also an open house because the main workshop is ended. If anyone would like to ask any question from anywhere under the sun, you can ask. And otherwise, you can fill the feedback form or you can drop off. It's completely up to you. If you have any question about teaching maths in any area, please feel free to ask me. I'll try my best, or you have your colleagues here, they can also ask. Anyone? No? Okay, then I'll give you the PPT here. I'll also drop it in the chat box, but I'll give it to you in the chat box here. And here is the feedback form again. Thank you so much. I'm just stopping the recording now.